Good morning, friend. Myself Jitendra Kumar. I am taking electrical machine design for electrical engineers. I belong to the electrical engineering department, and today we are just discussing about the DC machine construction features. This will be the lecture one. Under this, we are discussing about the DC machines. That what are the basically the DC machines are there, and what the construction features will be associated with the DC machine. A DC machine is an electromechanical energy alteration device. The working principle of a DC machine is when electric current flows through a coil within a magnetic field, and then the magnetic force generates a torque which helpful to rotate a DC motor. The same phenomena will be applicable for the DC generator. In case of the DC generator, we are providing the mechanical input and we are getting the electrical output. The DC machines are classified into two types, such as DC generator as well as DC motor. The main function of the DC generator is to convert mechanical power to electrical power, whereas a DC motor converts the DC electrical power to mechanical power. DC motor is applicable where the good speed regulation and ample range of speeds are necessary, like in electric traction system or a device where we are using a heavy loading. Then we are using this type of DC machines. DC machines have provide a high starting torque so that it can easily build up or it can carry the high load at the initial stages. This will be the construction of the DC machines. Over here you are finding that there is a outer cage that will be called the frame of the machine. There is a eye bolt. Eye bolt will be using just to pick up the motor from one place to the another one. So we are using the eye bolt. There is a there is a frame which will be associated to the many parts of the machine. Over here we are getting that there is a gasket cover, there is a gasket to frame. This part will be indicated as a to cover of the make the electrical connection of the machine. Either it will be a motor or a generator. There is a draining system. Draining system. Whenever there is any excess of oil or excess of water or anything will be entered through any part of the machine, then it will be drained out from this side. There is a protection to the inner part. It will be a covering of the entire machine, and you are finding that there is a white part. White part will be indicated as a cover, and the red part will be indicated as a inner part of the machine. So there is a shaft. That shaft will hold the entire rotor part of the machine. There is a rotor. Then there is a commutator or the rotor bars. Rotor bars are there, and the white part will be indicated as a rotor lamination. In between of that, you are finding that there is a white part is there. So that white part will be indicated as a insulation of the conductor. So conductors are aligned within this part, which we call the armature conductors are there, and all the armature conductors are associated with this part. This is called the commutator part of the machine. So over here we have the bearing, and just before of bearing there is a commutator part, and commutator part will be attached with the commutator segments, and that commutator segment are connected with the rotor windings. So this will be the structure of that one. And over the stator side, whenever we are just move on the stator side, there is a poles, there is a stator which will be wounding, and the copper bar you are looking that there is a copper bars are there, and that copper wire will be helpful in forming the poles. Then there is a end seal. There is a insulation which will be provided. Insulation are provided over the entire machines with the help of over. In case of the rotor, there is a rotor insulation over the stator. There is a stator insulations are there. The stator insulation are quite lower than as compared to the rotor insulation, because the stator insulation are the stable and it will be there is no movement are there. But in case of the rotor part, there is a movement of the rotor because rotor will be rotating in a specific direction. Then there is a fan. That fan will provide the cooling of the machine. Then there is a fan cover, conduit box to make the connection, Soft springer helpful just to hold the rotor soft and give a protection between the rotor and the end seal of the machine. There is a grease inlet. Grease inlet will be giving you the lubrication to the bearings, and this will be the exactly the structure of the DC machines. DC machines either it will be a motor or a generator, but the difference between the motor and the generator is that the motor it requires the electrical input and will provide the mechanical output. But in case of the generator, it will take the mechanical input and it will provide the electrical output. So that will be the basic difference between the DC machines or the DC motor or the motor generator. This will be the another the construction of the DC machines. Under this, you are finding there is a field winding which will be associated over there because in the previous slide we are finding that there is a winding which is indicated as a copper bar and their number the poles are there. So this type of machine is called a four-pole machine where two poles are indicated for the N side and two poles are associated with the S side and both poles are just opposite to each other and to and in opposite with the N S in opposite with the S. There may be the some machines are the two pole machines, so over there is one N and the one S. There is a commutator. They in between of that you are finding that there is a soft. Soft will be simply a rod where which hold the entire rotor part of the machine. Then there is a commutator segments. Each black part will be indicated an insulation, and that insulation will be a mica insulations are there. With the whatever white we are looking over this side, that white part is the commutator segments. So the entire commutator segment are connected with the rotor winding. These are the rotor winding that the small circle in the rotor part we are finding. That will be the rotor winding, or this part will be also indicated as an armature conductor. So each armature conductor is connected with the uh, commutator segment and help to give the current from either from the rotor part towards the outer part or the from the outer part towards the rotor part or the armature conductor will be excited by this one. So this will be the commutator segment will be helpful to make the connection between the rotating part to the stationary part. Over the commutator there is a brushes. Brushes are placed over the commutator, so it will helpful to just take out or take or give in the supply to the rotor part of the machine. Over the stator side, there is a poles. These are the poles are there, and this part is called the field pole shoes are there, and the field winding are placed in a line that line slanted line are there. There is a pole shoe. The upper part will be indicated as pole shoe, and the in between gap between the rotor and the stator. This is called the air gap because over here the air will be circulated within this one because whenever we are using over a DC machine, there is a air will be circulated within this one. So that air will be heat up or it will be helpful just to release the energy, release the heat which will be associated while the rotor is rotating within a machine. So that air gap is the most important thing because it will helpful to cool down the machine or it will helpful to make the connection between the rotor winding and the stator winding, and it will develop field flux will be produced by the stator part. The field poles are there which will develop the field of flux, and that flux will be linked with the north pole to the south pole. In between of that there is a rotor. So whenever the rotor is rotating, then automatically the EMF will be built up over the machine. These are the main components which are associated with the DC machine. One will be the yoke. Yoke is the outer part, outer body of the machine. Pole and the pole core. Pole and pole core are the stator part where the conductors, the field coils will be associated. Then there is a pole shoe. Pole shoe also will be associated with the pole and pole core. The pole shoe having the the armature, the field winding will be rounded over there. There is a field winding. It will be designed on the basis of the which type of machine are there. It will be heavy, high current machine or the high voltage machine. It will be wave wounded or it will be a lap wounded. Then there is a armature core. Armature core is the part of the rotor side, where the armature rotor part will be indicated in given the another name as a armature. There will be armature winding. That armature winding will be again in the same structure. It may be the lap wound or it will be wave wound or there. Then there is a commutator. Armature winding conductors are always associated with the commutator bars. So there is a commutator bars, commutator conductors are there, or it will be connected with the brushes. So these are the main part of the machine which will be associated over here, and we have to just concentrate about these things. And in the next during the next lectures, we are just discussing about all these in a construction point of view, that what how we have to just meet the size of the machines over there. And thank you for attending the lecture on the DC machine. Thank you.